Just wanted to give you the brief rundown on how you can get the SPI DAC to work with the Arduino. Now we've got some real hardware. You've probably already seen the simulation. What we're going to do here is kind of ignore some of the preliminary stuff for setting up the SPI. That has more to do with what we'll call the boilerplate of the code. And what we'll do is we're just going to initialize our little sine wave, and that's going to allow us to run through a wavetable. Here the wavetable, well, initially sine gives us -1 to +1. We add 1 to it, so that gives us 0 to +2. Then we multiply by 2040, and that gives us 0 to 4080, and that gets stuffed into our little sine table. Our delta theta is a global that is equal to 2 times pi divided by the total number of samples. We can change the number of samples if we want to make a higher precision sine table. What we're going to do in our little loop is we're going to index through the sine table. We'll have an increment called dx, and we'll change dx as a function of our analog read. We'll read from our little potentiometer, and that'll allow us to change frequencies. If we go outside the end of the array, we'll basically want to guard that array index. So if it's greater than or equal to n, we'll just set it equal to 0, and we'll start again with the increments. And then we'll do an analog read, get a value, divide by 32 because analog reads will return 0 to 1023, and that's kind of a high increment. So let's scale that down a bit, and then we'll just keep going around in this loop. This has already been uploaded to the Arduino. This DAC write is going to take a 16-bit quantity and shift out the 12 bits to the SPI DAC. And then, well, let's see how it works. And there you have it. So that's the long and short of it. I suppose if you wanted to, you could change this from sine to tangent or something. I haven't tried that yet. Re-upload the code, and then sometimes what happens is it doesn't work. Like now, it's silent. But if you hit reset, well, it's a pretty harsh sound. Sine waves sound way smoother. Tangents have all these asymptotes coming out of them. So there it is, the example using wavetables to create the SPI DAC sound, and this gives you a nice 12-bit DAC output. Hope you liked my little demo. Talk to you later. Thanks a bunch. Bye.